Aviation Academy, and I'm Captain Lakshmi Mohan. Last video we spoke about the 4 forces of flight. Today in this video we are going to talk about the 4 forces of flight, each and every single force elaborated. So first we have the weight, okay, the force that is there. And before we get into weight, let's talk about what force itself is. Force, if you look at the formula for force, it is force is equal to mass into acceleration. Now let's talk about weight. What is this mass and weight? What is the difference between mass and weight? Mass, if you see, is the sum total of all the atoms and molecules that is present in the matter, whether it can be your body, it can be any object that is there in this universe, any celestial body. The sum total of all the atoms and molecules that constitutes a particular matter is called as mass, and mass is going to be universally constant. Anywhere in this universe you go, the mass of that object is going to be constant. But on the other hand, weight is something different. Weight is a force. Weight is equal to mass into the gravity. So if you see the formula for force, its force is mass times acceleration. Now if you replace this acceleration with the acceleration due to gravity, now acceleration due to gravity changes from one celestial body to another. For example, if you go for the gravitational acceleration of Earth is completely different from the gravitational acceleration on Moon or Mars or any other planet for that matter. So the weight changes, the weight of an object or a matter changes with one celestial body to another. It changes with the gravitational acceleration. So if you see, there is a difference between mass and weight. Mass is the sum total of all the atoms and molecules of a particular body, whereas weight is a force. And when it comes to airplanes, the weight acts directly towards the center of the earth. Like I said, weight is a force and force is a vector quantity. Vector quantity means it has both magnitude as well as direction. So the magnitude of weight is going to be mass into gravitational acceleration, and the direction, that too specifically on the surface of the earth or on the atmosphere of the earth, is going to be to the center of the earth. So that is your weight, and weight always acts towards the center of the earth. Now this brings to another concept as center of gravity. Center of gravity is basically a point on the aircraft. It's an imaginary point, by the way, an imaginary point on the aircraft where all the entire weight of the aircraft is considered to be concentrated. All right, so now that is your center of gravity. All right, so now that you have understood what is center of gravity and what is weight, the force that counteracts weight in order for the aircraft to fly, and in the previous video we already know that weight in a steady unaccelerated aircraft, the weight is equal to the lift force. Now what is lift force and how it's created? So lift force is created on the wings of the aircraft, and how it's created is based on 2 principles. That is the principle of continuity and the Bernoulli's principle. So let me explain to you what is the principle of continuity. Principle of continuity is simple. That is the total volume or the mass flow of an ideal fluid, any fluid. It can be liquid or it can be gaseous form. So regardless, if it is moving through any pipe, okay, the amount of fluid entering and the amount of fluid exiting has to be constant always. It has to be the same. So in order for that to happen, there is a formula for your principle of continuity, which is the mass flow, the total flow of fluid, is equal to the area of cross section of the pipe, then the velocity of your fluid, how fast it's moving, and the third thing is the density of that particular fluid. Now let's take an ideal fluid. An ideal fluid is a fluid which cannot be compressed, okay, so its density is not changing here. So when the density is not changing here, the total mass flow is dependent upon 2 things, that is the area of cross section and the velocity at which the fluid is moving. Now let's say you reduce the cross-sectional area of this particular pipe. So if the area is reduced, what happens is that the velocity, so in order to keep the mass flow constant, something has to increase because we are reducing the area, right? So in an incompressible ideal fluid, the velocity will start to increase. So this is your principle of continuity. Let's keep it aside. Now let's move on to your Bernoulli's principle. What is Bernoulli's principle? We all have studied that in 11th standard, I'm sure. And Bernoulli's principle is nothing but the energy that is present in this entire system is always, the sum total of the energy is always going to be constant. Now, what are the two energies present in the system? There is kinetic energy and then there is pressure energy. Now, kinetic energy is the energy caused by the movement of any object. Okay. So in this case, the movement of the ideal incompressible fluid. So the kinetic energy here, it's also dependent upon the speed at which the fluid is moving. And like we said in the previous principle of continuity, the area is reduced, so the velocity is increased. Okay, so when the velocity is increased, what happens is that the kinetic energy is also increased along with that. So when the kinetic energy is increased along with that, in order to, according to the Bernoulli's principle, the sum total of all the energies is supposed to be constant. So here what happens is, when the kinetic energy increases, the pressure energy has to decrease. So what happens is that the pressure decreases, or the pressure energy decreases, and when the pressure energy decreases, what happens? So the same thing can be converted into an aerofoil. Aerofoil is the shape of your wings. Okay, the cross-sectional shape of the wing is called an aerofoil. Now, the same idea is applicable even when it is half. Okay, when you see in the diagram given here, you will see that even if you cut the top part of it, the fluid dynamics is going to behave the same way. Okay, so as you can see, the higher, there will be low pressure on the top part of the aerofoil, and there is going to be higher pressure on the bottom of the aerofoil. Now this pressure differential between the top part of the wing and the bottom part of the wing is what creates lift. Okay, and lift is not just dependent upon the pressure difference. This pressure difference, another word for this pressure difference is coefficient of lift. And lift is dependent upon three things basically: the coefficient of lift, then you have the dynamic pressure, and the surface area, wing surface area. The more the surface area, the more the lift created. The more the dynamic pressure, the more the lift created, and more the pressure differential, more the lift created. So this is basically how lift is generated in an aircraft. Right, now that you have understood what lift is, so the next force that we are going to focus on is drag. Before we get into drag, I need to explain to you three different concepts or three different terminology. So let's get into that. So first of all, I need to explain to you what is relative airflow. Relative airflow is the flow of air which is against the flight path. The magnitude of the relative airflow is going to be the same as your true airspeed, and the direction will be exactly opposite to what the where the aircraft is moving. Like let's say the aircraft is climbing up. What happens is the relative airflow is exactly opposite to that. When the aircraft is descending, it's opposite. And if it is straight and level, it's exact. So whatever is your flight path, the exact opposite direction is your relative airflow. Okay. And the second thing that I want to explain is your chord line. Chord line is an imaginary line which is connecting your leading edge, that is the front part of your wing, to the trailing edge, which is the back part of your wing. So it's an imaginary line between the leading and trailing edge of a wing of the aircraft. So now if you see, the third thing that I want to explain to you is angle of attack. Angle of attack is simple. Okay, like I explained to you the relative airflow and the chord line. The angle that the aircraft creates between the relative airflow and the chord line is called as your angle of attack. Okay, so now keeping this angle of attack, and when an aircraft is when you think about it, this is basic theory physics, but practically if you see, when an aircraft is flying in the air, what happens is that there is going to be a little different concept called effective airflow, which is a practical version of your relative airflow. Now this practical version of this relative airflow, what happens is that the lift generated will always be perpendicular to this airflow, relative airflow. Now with relative airflow, what happens is that if you see in this diagram, you will see that there is an you can see it as a TI. TI is basically the total force that is acting on that particular aerofoil or that wing. Okay, now with this total force that is acting, you can see that it can be divided into two segments, that is a horizontal component and a vertical component. Okay, so the vertical component is your lift. Okay, from the total force, the vertical component is your lift, and the horizontal backward component that you see is an induced drag. Let me explain to you in words that is much more simpler. Like for example, you're in a car that is speeding. As a child, maybe you all must have done this. You go and put your hand outside in a moving car. You should not do that, but still, if you put your hand outside, you will see your hand goes up and also it goes behind. Okay, the force that is making it go up is your lift force, and the force that is making it go behind is your induced drag. Okay, so induced drag is nothing but a byproduct of the lift force. Okay, so that is there are two types of drag, by the way. So induced drag is one type of drag which is inseparable from lift. So every time lift is created, induced drag is created. The more the lift created, the more the induced drag created. Okay, so that is about your induced drag. Now let's talk about the other type of drag, which is called as parasite drag. Parasite drag is caused by the presence of the aircraft, and that is the interaction of the aircraft with the air is what causes your parasite drag. Now parasite drag is divided into three types, that is your foam drag, interference drag, and skin friction drag. Now foam drag, let me explain foam drag to you with something that you can relate to. Let's say you're standing on top of a bridge. Okay, when you stand on top of a bridge and you look down onto the river that is flowing, let's say. Now when the river is flowing, let's say you are between two pillars of that bridge. Now you'll see that the river or the water is flowing very smoothly and very fast in the middle of these two pillars. But if you go look around that pillars, what is going to happen is that the water flow slows down, and not only does it slow down, its direction moves around. It creates a turbulent flow. The flow that you see in between these two pillars is called as laminar flow, and it is faster compared to the turbulent flow in all directions that it is moving around the pillar. So this is an example for your foam drag. That means if a particular shape, that is your aerofoil shape that the aircraft, all the aircrafts are designed in, is the most efficient way to counteract this foam drag. So if anything is stopping the flow of air around the aircraft, that creates a foam drag. So in this diagram, if you see it, this is a perfect explanation of what a foam drag looks like. You have a flat plate, you have a sphere. See how much turbulence it is creating, and compared to sphere with fairings and sphere inside a housing, all this is the example of how your drag changes with the shape of the object. Okay, now moving on to the next type of parasite drag, which is your interference drag. Now interference drag is pretty simple. If you take just the fuselage of the aircraft, okay, and put it through a wind tunnel and you measure the drag, you get a certain amount. Let's say you get around 1000 newtons of drag. The next thing, you just take the wings of the aircraft and put it in a wind tunnel and measure the drag. Again, let's say you get 1000 newtons of drag. Now if you put it together and put the fuselage and the wings together in a wind tunnel together, you will expect to find around 2000 newtons of drag. Yes, but when you measure the drag, it's not going to be 2000, it is going to be, let's say, 3000 newtons of drag. This extra 1000, again I'm exaggerating to explain it to you. Now this extra 1000 newtons of drag, for example, is your interference drag, which is created by the interference between two intersecting sections. That is, this is your fuselage, this is your wing, and in this area it creates something called as interference drag. Okay, so that is your interference drag. And lastly, when it comes to drag, the last form of drag is called as your skin friction drag. Skin friction drag is nothing but the tiny microscopic imperfection that is there in your fuselage skin or in your wing, the skin of your wing or any part of the aircraft for that matter, when it interacts with the molecules of air, it can kind of create a friction between the both of them. This friction is called as your skin friction drag, which slows down the airflow. Okay, so this is called as your skin friction drag. So like I said, there are two different types of drag, the induced drag and parasite drag. Parasite drag is further divided into foam drag, interference drag and skin friction drag. Alright, now so we discussed the three forces of flight. Now let's discuss the force that counteracts your drag force, which is your thrust. Now thrust, we all know, is another force which is provided by the engines of the aircraft. Okay, now if you see, there are two types of engines. Okay, we have the piston engine and we have a jet engine. So either of it, again, thrust is also another form of force. Okay, so now again, force is mass into acceleration. So let's take an example of the piston engine or a piston engine attached to a propeller. With a propeller engine or a piston engine, what happens is that the airflow that is there, there is a huge amount of airflow, huge amount of air is accelerated. The acceleration is less, but the amount of air that is moving through the engine is going to be high. Okay, so here force, again, the forward thrust force is created by large amount of mass but not as much amount of acceleration. Whereas in jet engine, which is the most efficient engine comparatively, in jet engine what they do is they take small mass of air and accelerate it very quickly. When it's accelerated very quickly, what happens is that again, thrust is created. Again, force, like I said, is mass into acceleration. If you increase either of it, you are still going to get thrust. So it's either you can increase the amount of the mass of your airflow, or you can increase the acceleration of the airflow. Either way you get thrust, which counteracts drag. So in total we have four forces. We have the weight, which is counteracted by lift, and we have drag, which is a byproduct of lift, as well as the motion of the aircraft through the air, which is counteracted by thrust. That's all for today. Thank you, and you all have a good day.